Hello, everyone. Welcome to our Uptime webinar today. My name is Amissa, and I am the Director of Engagement here at Uptime Solutions. I'm super excited to have you all join us for Inside the Mind of a Cat 3 Analyst. We have one of our analysts on this webinar with us, and he's going to be telling you what your assets are telling you through data. So let's talk before we jump into the webinar about how you can participate. So during the webinar, if you have any comments or any thoughts about anything we're talking about, feel free to add those comments in the chat and we will respond to those. And then also there is a question mark icon where you can type in any questions that you have. We do have time at the end for Q&A where we will address any of those questions at that time. All right, without further ado, let me introduce you to our featured speakers today, Brian and Todd. Brian, do you want to give us a little bit of an intro about you and your background?
Sure. Thanks, Amissa. Yeah, thanks everybody. Glad to be here. My name is Brian, the Vice President of Maintenance Programs here at Uptime Solutions. I've spent the better part of 20 years from heavy equipment mechanic to maintenance manager to director of maintenance and reliability to an executive for a tremendous amount of state programs around the country. So I spent a lot of time building maintenance and reliability programs and leading a lot of teams from the shop floor all the way to the C-suite. So happy to be here. Thanks again. And go ahead, Todd.
Thanks, Amissa, and hello, everyone. My name's Todd Koch. I've got about over 25 years of experience in reliability and condition monitoring. Currently hold a Cat 3 certification, among others. I've been the monitoring lead manager for Uptime Solutions for over 5 years. I've been everything from a tech that's out collecting data, route data. I've been a supervisor for the reliability department. Glad to be here and excited to share my thoughts and my experiences.
Thank you, guys. Thanks, Todd. All right, so what are we going to talk about today? Well, one, you're going to hear a lot from Todd about what a certified analyst looks for in condition monitoring data. He's also going to talk about some common patterns and failures seen across facilities. Um, Todd and Brian are going to talk about how you can turn prescriptive recommendations from an analyst into maintenance actions. And then Brian's going to touch on how maintenance teams can actually execute on those recommendations. And then we'll do a wrap up and some Q&A at the end. So, why are we having this webinar? Because we feel that, analyst-driven condition monitoring, maintenance, having those as a foundation for a maintenance program is really important. And the reason is because we all know that unplanned downtime is pretty costly. Depending on the facility, it can vary how much that costs, but that's a problem, right, that we all face. And the risk of not doing this style of monitoring and maintenance is that you miss early warning signs. So these are signs that you could see early and do some simple adjustments or addressing those issues early to prevent like the inevitable failure that could happen. Also, if you're doing calendar-based PMs, things can get overlooked that analysts are trained to catch. And then expert analysis can turn condition data into clear, prioritized maintenance actions. So you're doing work to address those things versus just randomly doing work to do work. All right, so Todd did give a little bit of an introduction of himself, but I really want to dive in and learn more about you, Todd. Can you tell us about your career? How did you become an analyst? What are some of the things you've seen over the years? We'd love to hear more about you and your experience.
Thanks, Amissa. Well, I started my reliability and condition monitoring career back in 1999. I started out in a small motor shop where I worked in a what we called the field services group, and I ran route-based vibration routes at different facilities. We did laser alignments, balance work, motor removal, and installation. I left there and went to a wood products facility and started the vibration program there. After that, I went to a well-known data collector company and worked there for a short period of time. And then I got into the paper industry. After that, I went to as an instructor for a short period of time, and then I saw that I really missed the field and the diversity and the different applications that I was not exposed to, and I missed it. And so I went back into the paper industry and moved around to several different companies, and I'm now with Uptime Solutions as their monitoring lead manager. Through the years, I've held many certifications I currently hold a Cat 3. I've done the motion amplification and field balancing, thermography. I've done the operational deflection shapes and modal analysis. I've got 25 plus years in that in all types of industry, mining, the paper, chemical, aluminum, steel, building materials, package sorting, power generation. I've seen a lot of different applications and different facilities, and it's a passion of mine, and I really enjoy what I do.
Awesome. Thanks, Todd. You definitely are the right person to be talking in this webinar. We're lucky to have you with all of your experience.
Thank you.
All right. So tell us, Todd, what does an analyst actually do on a day-to-day basis?
So, in the first thing we do is look at our alarms from the system. And that may be something that has jumped up and has alerted us that there's a need for analysis. It may be something that we've seen for a while, and we know that there's a continuing condition there. It's just alerting us that, hey, this still is there. And so from that, we look for pattern recognitions for bearing faults and different abnormalities that may show up. And we'll look at our emails from the customer to see if we've had any interaction between them of findings or anything that they have note of. And then, from that, we would communicate to them that, we need to do this extra action item, or we need to dig a little deeper into this piece of this asset to see if there's something that we're missing, that we inspect a piece of equipment and maybe we don't find something. Well, we dig a little deeper. And so that's how we support the maintenance team there. And we communicate between them and help them identify and repair the items that may cost them unscheduled downtime.
Awesome. Thanks for giving us a high-level overview of that. I know there's a lot more that goes into that, but that's a great overview. So being an analyst over the years, I'm sure you have a lot of experience, it sounds like, with a lot of different types of assets and data. What is like the volume and variety of data that you've seen in your career?
So I looked at this, and a rough estimate I would say would be around 100 to 200 asset points in a daily in a given day. And that really is dependent on the analyst, his experience, his familiarity with the equipment, the site. And, he may be able to get through more of that. And he may be able to get through less if he's a newer analyst that really is trying to learn the data and look at and try to dig into the data to see what the issues may be, looking for bearing frequencies, looking for electrical frequencies, and looking for things that we see on a daily basis. And the types of assets what we look at is motors and pumps and gearboxes and fans. And but to me, the more complex assets, that's what really excites me. I like to be able to dig into that and really get down into the roots of what the problem may be, and the more complex problem, the better for me. And we look at all type of industries. The paper industry. We look in the water plant facilities, the wood production facilities, the package delivery facilities. I really think that anything that has a rotating piece of equipment, that's where we really need to be.
Nice. Awesome. All right. So in your tenure, What are some of the most common issues that you're running across that you see in the data?
So one of the biggest things is the bearing degradation. That's the key for the vibration analyst to find is a bearing failing. That's one of the most costly items that could fail in a piece of equipment, a motor, a gearbox, because from that bearing degradation, it creates additional failures and additional problems for the equipment. We look for misalignment and I kind of debated whether I wanted to tell this story, but in my youth, I really didn't understand what how to do an alignment. And so late one night in a coal mine, me and a partner of mine were working through the night to repair some alignments that we didn't properly do. And we knew they weren't properly done, but we figured it was close enough. So the customer called back and said, "Hey, y'all need to come up here and redo these alignments because they weren't right." So we drove up and we worked through the night to repair these alignments. And it took us actually picking the motors up off of the base, clearing coal out from underneath these bases, just so we could get the motor in the right position. And that's really when I learned how to do an alignment, because you want to get everything to zero is when you're first learning, but sometimes you don't have that ability, so you have to angle the shaft into the center of the other shaft. And so that's one story I had about when I learned how to do an alignment. And we have lubrication issues that show up in the data, and it's really satisfying to have that ultrasound measurement that you see is increasing, and you tell the customer, "Hey, would you go out there and put a couple of shots of grease in this bearing?" And then through the data, you see that ultrasound measurement go down, and that's satisfying, knowing that you've elongated that bearing life for that customer. And a lot of people, they talk about electrical issues, and when we say, "Oh yeah, we can find electrical issues in vibration," they're really surprised. But yes, we can find electrical issues in there as well. And so, I put this in here about the transient anomalies that we find in the data, in the process data, and with the amount of data that we collect through the wireless condition monitoring, we'll see conditions with process flow of water, of paper, a pulp, and different things that could save a company, from downtime where they have an ongoing process issue. And it's really exciting of everything that we can see in the data. And we find a lot more, but I'll leave it at that.
Awesome. Thank you, Todd. It's very enlightening. Um, so what do early warning signs on the data look like? Like what do you see when you see like, oh, something might be going on here?
So as the graph shows there, our first indication is an increase in the ultrasound or the ultrasonic reading. And to me, that's kind of the band-aid stage. We're putting a band-aid on this failure and helping the customer give longevity to that bearing to where they can go another 6, 8 months, a year and on that bearing. And so, that's the earliest stages of that we catch of an early defect. And so we move into the vibration stage, where I look at that as an opportunity for the customer to plan that downtime in a timely manner, and being able to repair that at their time, at their leisure. And that's the time where you may not have unrepairable damage occurring to a shaft or a fit that's in a bearing. And so to me, that's the ideal time to actually start to repair that equipment and fix the issue that's coming up. Once we get into that temperature range, that's where the cost starts increasing, and other damage starts occurring, fits get lost, and there's shafts have to be repaired or rebuilt, and that's all costly and time consuming to the customer. And so we look for those changes over time from the onset of the ultrasound all the way to the temperature range. And we see that in our trending of a defect. We can see it from the ultrasound all the way through the temperature. And we want to catch it in the ultrasound and give it more longevity, but at the vibration stages when that needs to be repaired.
Nice. So you're able to give people the earliest warning sign and then they can plan and schedule repair at a good time to where they're not compounding effects of cost on repair when they get into that temperature phase, that sounds like.
Correct.
Nice. Cool. All right. So what are some assets that get missed in monitoring that you think shouldn't? Because we know that companies usually have criticality assessments for their equipment. Um, but I'm sure you've come across some pieces of equipment where people are like, eh, maybe I don't need to monitor that. But from your experience, what are some of those things?
Yeah, the the non-critical and or the spares, you might say, some of those are often missed in a condition monitoring program because, it's a spare. It's there to back up the primary. And so most of the time when we go to a customer site and we say, "Oh, you have a spare for that piece of equipment, so maybe you don't want to monitor that." Well, the spare is just in as bad a shape as the primary is. So, that's a good case of monitoring both of those because you have you would have equipment in good standing and good repair to be able to back up your primary. And we see that a lot from, a lot of places I've been to, I've seen that.
Mhm.
And you know, I see a lot of conveyors out there that and I've done it myself. Is we don't really monitor those pulleys and the heavy take up pulleys, and some of those take up pulleys are 1,300 pounds, and which really surprised me. And to catch those components and to catch those when they start failing is a big cost because there's those things are heavy. Design issues. Um, a lot of times when you go to a facility and a customer puts a piece of equipment in, puts a piece of equipment in, and they start it up, it starts vibrating. It may be due to design issues. And so, to have that initial baseline data, you might say, is critical to know what kind of condition that piece of equipment's in. And,
Mm.
a lot of times fans, blowers, and auxiliary equipment gets passed over due to, cost restraints, and that may cost you some unscheduled downtime as well.
Mm. Thanks, Todd. And Brian, from a maintenance perspective, like what are some assets that you've seen that should be monitored that sometimes get overlooked?
So it's just very straightforward. Compounding effects. If you have assets, a lot of people look at assets to be monitored from solely operational impact. But we need to look at compounding effects. We need to look at assets that could potentially cause a risk to environmental health and safety, compliance, standby labor cost, production capacity issues, customer trust. There's all these things that can impact our ability to continue operating effectively and generate business. And I just challenge everybody when they're doing condition monitoring asset understanding is to look at compounding effects, bottlenecking, all these other sides of this stuff, right? Because at the end of the day, we should be looking at severity, occurrence, and detection, and how they rank to determine how we should monitor them or if we should monitor them. But keep in mind, compounding effects is a very real and often missed thing.
Can you give me like an example of that or like what that might look like?
Yeah, sure. So say we have like a bottling line, right? And the bottling line, you know, I'm not super familiar with bottling lines, but we have a bottling line and it's generating bottles and they're getting capped at one end, right? Well, if you have an asset that's sending bottles down through and that has a disruption or has a defect or a problem, the downstream effect of that is now you have another machine sitting idle, which has an OpEx cost. You have people standing by, which is an OpEx cost, right? So there's all these things, particularly in manufacturing, high speed manufacturing, where something has to happen before another thing happens, right? So always think of those types of things.
Okay, thanks for that. All right, Brian, from a maintenance perspective, what are some common maintenance blind spots when it comes to condition monitoring?
The biggest one is not doing anything with the data. Collecting data doesn't do anything. Collecting data doesn't make you reliable. Collecting data doesn't fix your assets. There's a common misconception that if we just have a bunch of data, we will get better and we'll be reliable. That's not true. Action from data is how you get more reliable, and create more availability. So big things here are not using condition monitoring data to modify your PMs. We should be looking at defects, and we should develop PM tasks that are directed at those defects, or at least uncovering those defects. Um, a lot of data, as I mentioned before, is generated, but almost none of it is reviewed, right? So if you're collecting a ton of data and no one's looking at it, the trust in that data then becomes diminished. So collect pertinent, accurate, and informing data, not just data to collect data. Um, Alarms, right? We talk about, alert overload, where things are constantly beeping at you and pinging at you all day long. And if those things are non-value adding and people ignore them, well, everybody else is going to ignore them, and they're not generating any real value. We see that a lot with our competitors, where it's like, yeah, it'll alert you if an anomaly is detected. It's like, well, cool. What does that even mean? And what do I do? And then this is the biggest one: is the lack of feedback. So if an analyst makes a prescriptive or a recommendation on inspection or corrective repair, we need to be documenting that and understanding that, and then providing that feedback back to the analysts so they can then make sure that the things they're doing are right on their end, and they can note those defects that they're seeing in the data, and they can keep an eye on those things, and then they know when they see those things again, they can make a good prescriptive recommendation that's based in reality because we confirmed it on the back end. So that feedback loop is very important.
Awesome. And then Todd, from an analyst perspective, you've been working with a lot of maintenance teams over the years as an analyst. So what are some of the blind spots that you've seen that some maintenance teams have had?
Yeah, I'd echo what Brian said. The out of date PMs. I've looked into some of the CMMS systems, and I've seen the PMs are from like 1989, which those would be considered outdated to me, which might need some revamping or re evaluating. And the inspections are very important. And so I had another story, if you don't mind, about a Friday evening. I got a call from a friend of mine that was working on a fan at a facility, and he said, "I can't get this fan to run. It keeps tripping on high vibration, and I can't get it to run to balance it." And the balance was at 100 mils of vibration for unbalance, and that's pretty severe. And this was a heavy overhung fan, probably 6 to 8 feet in diameter. And I drove up that Friday evening, and we went to the site Saturday morning. And when I got there, we tried to run it, and of course it was tripping out. And so I asked him, I said, "Have you looked at the fan? Have you inspected the fan to see if there's something visibly wrong with the fan?" And so when we opened the hood up and looked in the fan, part of the duct work with inside that fan had come loose and was wrapped around the fan, and wasn't allowing us to get it up to speed. So once we removed that and had the fan back to a good condition, we were able to balance that fan and get it back in operation for the customer. So, those inspections are very important. And like the data that we collect in that. And I was thinking about that this morning about, that data that we collect and put in the CMMS is just not for uh, the the mechanics there now, the millwrights working on it right now. It's for those generations that are coming that may say, well, has we've seen this problem in this pump before, and they say, well, millwright such and such seen it probably 10 years ago and he's gone. Well, we can look in that CMMS and see that data there. And that's where that feedback comes into play for the generations to come, as they have that data, they have that experience there that they can fall back on. I think that's very important for a maintenance department and condition monitoring team.
Awesome. Thank you guys. This was really good information on those blind spots. Now let's shift gears a little bit, Todd. Let's do story time and tell us a story about in a time when you caught some early warning signs on some assets and what happened, how that went, what the outcome was.
So this was a facility that we went in and evaluated. I was actually on site for the evaluation, and I saw these small fans, like three of them in a row, and I was like, well, we really don't want to monitor these fans, or I don't really don't see a need for it because they were pretty small and felt that they could be worked on pretty easily. So in the install, we had some sensors left over, so we said, well, let's put some on these fans. And so when we did that, we found this motor that had a bad bearing in it. And so the customer changed that motor out and the vibration returned to normal, prevented that costly downtime that may have shut their line down for a period of time. And that was a good find. I felt that that was something that really surprised me because I didn't see the value in adding sensors to that. But that just goes to show you that that non-critical or that secondary equipment that we don't think is important could cause us some downtime. And this customer, they changed the fan out or the motor out, but the fan still has some unbalance in the fan that we're going to address later.
Nice. So, and now they have an early enough warning to be able to schedule that out, right, at a better time, it sounds like.
Correct.
Nice. Awesome. All right. Tell us another story about some early warning signs and data you've seen.
Yeah, so yeah, I picked some that were very recent, and this was just back in December, early January, where we caught this bearing increasing with bearing fault frequencies, and this application is a very heavy roll that probably weighs in excess of 30,000 pounds, and so when we found this, we were trying to let the bearing life uh, go a little longer. We're trying to make it to an outage. And we saw that it kept getting worse and worse and worse. And we finally decided to pull the bearing and replace it. And the picture below there is of the actual bearing that came out of that application. And you see significant spalling in the outer race, which that's the defect frequency that's showing in the FFT or the spectrum. And that call was a good save for that company to increase production and being able to change that out in a timely manner before it failed, and destroyed shafts and destroyed bearing housings, and maybe even uh, that whole section of this piece of equipment could have been destroyed.
Okay, so it sounds like you were able to catch it early before further damage would happen to that equipment. Sounds like a
Yes.
lot of bad things could have happened.
Yes.
Yeah. Okay. So Todd, tell us about some of the biggest challenges about being an analyst.
Yeah, some of the challenges we have is, you know, the recommendations not being implemented in, that we see could be detrimental to the process of a company. And if they let that go on long enough, there's damage that could occur that could cost them more, and it's concerning to us to see that those recommendations not implemented. And so, you know, we don't get we don't get the repair and failure feedback that Brian was talking about from the repairs that get done. We like to hear that from the customer of, hey, yeah, we found that this bearing had failed, and we were able to change it out without the shutting the line down after we went down for a short downtime. And that's what we like to hear. The analyst loves to hear a success story from the customer, and it builds his confidence. It gives him satisfaction of knowing that he caught something. And one of the in the field when I was working, one of my best satisfaction is when I would balance a fan and that fan would run smoothly. I mean, it's so gratifying to have that happen. And the limited context from the field of what they found on a coupling. Was a coupling destroyed when we saw vibration that was identifying that? Did they find loose bolts? Did they find a broken foot on a motor? That information that we get back from the field is critical to the success stories of not only the condition monitoring team but also the maintenance team.
Okay, thanks for going over those challenges with us. Um, Now, let's talk about what makes a good prescriptive recommendations from an analyst point of view, right? So you're monitoring data from an asset. You catch something, and now you got to tell the team, "Hey, here's what's going on. This is what we need." Like, what makes a good prescriptive recommendation in from your perspective, Todd?
Yeah, a clear problem description that has information associated to that asset or that point. And you don't want to send something to a customer that says the vibration has increased, inspect, because that could lead to a very it's just not very intuitive to the mechanic to be able to go out there, because I will go out there and I will look at this piece of equipment and inspect it. And if I don't see anything visibly wrong with it, I'm going to report back that that piece of equipment looked fine to me. I mean, I inspected it, it didn't appear hot. It didn't have any rollers falling out of it. It appeared to be okay. And, a clear problem description would be if vibration has gone up into this piece of equipment. The signature looks like it's showing looseness. Check the shaft lift for shaft fits between the bearing and the shaft and the bearing and the housing. That gives the mechanic a clear identifying things to do of, I need to check the shaft lift on this particular point to make sure that the shaft is not loose on the bearing or in the housing. And that's the steps that the mechanic can do. And, that's based on his experience. And we see that all the time where we will put in a notification or a work order and tell them to inspect something, or, hey, um, the one times in the shaft speed has gone up, check for loose bolts and check for looseness in the structure. And so those are actionable steps that somebody can take, not just, hey, the vibrations increase, go check this piece of equipment out. And
Yeah.
so we base our priorities off of three priorities. Priority three is like a monitoring or a watch list item. A priority two is like action is recommended, and a priority one is action is required. So that's kind of the priority that we base and give to the customer, so they know that how severe something is.
Okay, thanks, Todd. And then Brian, from a maintenance perspective, if you're working with a condition monitoring company and an analyst, and you receive a prescriptive recommendation, what does a good one look like to you? Like, what's useful and helpful?
I just want one thing. I want context. I want to know that the recommendation is based in the contextual operation of that asset. So, and I'm alluding to something here. Analysts should be in the mills, in the plants. They should have walked those assets. They should know how those assets are coupled, how they're driven, what type of frame size they are. Are they driven by a VFD? Is it a gearbox? Is it multiple shaft gearbox? Is it this type of coupling, that type of coupling? I care more about context because that is going to give us an accurate understanding that the analyst knows what they're talking about. If an analyst says, hey, X, Y, and Z is a problem, and we believe this because of contextual A, B, C, and D, then I know that they're really in it, right? But if I
Mhm.
get a recommendation, is like as Todd alluded to, inspect bearing. What does that even mean?
Mhm.
Or check bolts. Cool. What does that mean? Right? We need
Mhm.
context. We need to know that that person who's looking at that data understands how the things are actually functioning in the business.
Nice. Awesome. Thanks, guys, for that. So now here's where we shift the focus of the webinar a little bit. We've heard a lot from Todd about analysts and data and assets and what that looks like. Now we're going to shift to the actual maintenance actions of it. So Brian, how can a maintenance team turn prescriptive recommendations into actual work? Like, what does that look like?
Well, one of the first things is to integrate, right? The analyst and their team and their technology is speaking one language and they're learning or they're analyzing and they're doing their expertise. The people in the maintenance department not always have that expertise, right? So a nice thing to do is to integrate with your CMMS, your EAM, whatever, so that when analysts are making work recommendations based on the criticality and the priorities that you mutually have established, they can get dumped into your CMMS as corrective, preventive, inspection, reactive work orders, right? So now the common understanding in the system is there, so that people who don't know how to use Upcast or analyzing software, they can look at a work order and go, oh, this is the priority that I know, and the analyst knows this is what their recommendation is. I can do those things. So integrate where you can. It creates a lot of transparency and value, and it's also a historian. You want to, if an analyst makes a recommendation, and you go do it, it shouldn't just disappear into the ether. You need to track it on a work order. In maintenance and reliability, we speak in work orders, right? Prioritizing work. I want an analyst or company that I'm entrusting, I want them to use the same priorities that I use and the same language that I use. If, as Todd alluded to, we use PM1 or sorry, priorities 1 through 3, then we need to align on what that 1 through 3 is. And it needs to make sense within our business and how we assign those things. So there has to be a lot of transparency there. And then aligning your PDM with your PMs. I mean, that's just basics, right? If you're just doing a bunch of data analytics and you're not using it to drive any kind of action or value at the shop floor or your asset management strategy or safety or defect elimination or anything like that, there's no point in doing it. You've got to have these processes and this data actually impact your business far beyond just looking at data.
Awesome. Thanks, Brian. And then when you're getting that work and you're turning these prescriptive recommendations into actual work, how can a maintenance team execute those without disrupting operations? Obviously, operations at some point might have to be disrupted, but optimally, how can they do that?
Yeah, well, we all know here that planned downtime and unplanned downtime is still downtime, right?
Mhm.
So there's trade-offs that are given for certain one each of those scenarios. So the best thing you can do, and this goes beyond just condition monitoring, is plan and schedule work. Dedicate people and resources to looking ahead and how we're going to manage the workload and the condition-based information coming in. Plan and schedule. Do it well. At the end of the day, anyway, a strong analyst and system should be giving you long lead times, several weeks, months, sometimes a year, right? Planning and scheduling windows should be several weeks in advance, months in advance, right? If you're planning in the same week, you're not planning, you're reacting, right? So that is a huge one. Coordinating with production. I believe that if you have analysts on site doing your monitoring, they need to be in the production schedule meetings, or they need to be talking to the planner and the scheduler all the time, right? So that there's a free form of information flowing and transparency there. So everybody knows where everybody stands and what needs to be done. Integrating the condition monitoring data through a planner or through the analyst to the production schedule is invaluable, right? And if you have strong planning and scheduling that's in line with your operational capacity and timelines, then you're even better off, right? And then the 2 first bulletins will impact the third. Okay, if you do all those things correctly, and you build out those processes and you do the right things and you build the relationships and you get people in the meetings they need to be in and you act on the data, downtime inherently will be minimized. Just planning and scheduling work will inherently minimize your downtime.
Thanks, Brian. You and Todd have both kind of alluded to this a little bit earlier. But what's your recommendations on closing the loop with an analyst when you're working with them on condition monitoring programs?
At its simplest form, let them know what you find. Whether they're right or wrong, they need to know that, right? If they're wrong, tell them, hey, you had mentioned, A, B, C, and D, and we found C, D, and E. And cool. And then they might go, oh man, you're right. I saw a different data set that kind of alluded to that, but this one was more prominent. So we went this route, right? So it helps them dial in, and it also helps build the trusting relationship that you're confiding in each other. So it's not just, oh, the analyst said it and he was wrong. Ha, 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 ha. Right. In that scenario, you both lose. So the feedback is super important. And the follow-up saying, but we should track that data, right? So the reason we talked about CMMS prior and integration is these things should be generating work orders. And if you've got any work order management set up somewhat correct, you should have cause correction confirmation or failure codes and failure modes within your work order so we can know these things and keep track of it. Um, and then all of this at the end of the day will build trust in your condition monitoring program because you've now established relationships that are a two-way street and communicating. And we're using the data to then better leverage our core functions as a business. Then we start trusting it. Hey, Todd made this recommendation. He was right. Hey, this guy made this recommendation. He was slightly off, but we learned from it. And now we have a whole new data set that we can pay attention to for longer failures, right? So it's all give and take, but they have to be in the loop. Especially if they're remote, that's even bigger, right? And if you're not remote, you need to be ingrained into the maintenance and reliability organization at that facility.
Awesome. Thanks, Brian. So overall, how does all of what we've been talking about and then a condition monitoring program improve maintenance strategy?
Well, all of these, right? So you are likely to have fewer emergent repairs, right? Whether that's planned or unplanned, likely unplanned. Failure is going to happen. You're not all this nonsense. You're not going to eliminate failures. Failures are going to happen. We mitigate risk, right? And we give the longest lead time to prepare for that risk. And that's why the longest window that an analyst can give a company based on asset condition is so important because we want to mitigate risk. Failure has already started. If you can pick up a defect, failure has already started. So you're not really predicting anything, right? So that's a huge one. Better planning, as I stated in the last slide. If an analyst and the technology should be giving you several weeks, months, maybe a year plus out of a window to understand the context of these failures. The longer that lead time, the better the planning. Oh, we can wait till the next scheduled outage, and it's not going to affect production anyway because it's already scheduled. Or, hey, I'm going to get with operations, and in a month and a half, we're going to all accept that we're going to take a 10-hour downtime to do X, Y, and Z, right? So that's huge. Longer asset life. If you're monitoring defects, it's very likely, if you're using that data in the right way, you want to eliminate some of those defects or at least modify the design to a point to where you get a longer service life out of that component. So we can't increase reliability beyond the design, right? But if we can change the design, then we can get more availability, more service life out of those specific components. So that data is super invaluable, right? We can't walk up to a machine and know the vibration frequencies and all the crap that Todd's looking at on a day-to-day. We can't see the ultrasound, right? So you have to rely on that data to make those good informed decisions to then benefit the life of your asset. And then this is a huge one. It's often very missed. Use what you learn and make yourself better at the most core function you can, which is your preventive maintenance strategy, your planning and scheduling, right? How are we going to maintain this asset, right? We want to know, we want to have those eyes on the things. We want that data from the things that we can't see, touch, feel, whatever. So they're all super important, but they all complement each other.
Awesome. Thank you, Brian. All right, we're coming near the end here. We're about to get into Q&A. Before that, I'll do a quick summary. So some key insights here. Data-driven maintenance starts with insight, with an analyst, with condition monitoring. Analysts see patterns that you can't see in person and that you can't see alone, like Brian just mentioned. You can't always see visually what's going on with an asset, so the data is important. Also, the action turns insight into reliability. So being able to have these recommendations, doing the right work on the maintenance side can improve your reliability program. All right. Real quick, I'm going to do a plug since we are Uptime Solutions. I'm going to do a plug for Uptime Solutions. So one, though, the recording will be sent out after the webinar if you're wanting that. We do offer a Uptime Up Now pilot program. And quickly what that looks like is you get 60 of our 3-in-1 sensors. So that's ultrasound, vibration, and temperature in one sensor for 60 days of monitoring for a flat $2,500. No hidden fees in there. And we do the install and the monitoring and everything for you. If that's something that you're interested in, you can email us directly. That's my email address there, Brian's email address. If you have more questions, feel free to reach out and email us. And now let's get into Q&A. Brian, I can't see the Q&A. Do we have any questions put in there? Okay. If you guys have any questions, now's the time to type them in. Otherwise, let's go over a few of these that we have. So, Todd, from your perspective, what is the most common early warning sign you see get overlooked in condition monitoring data?
Yeah, we talked about it earlier, Missa, and I think of the ultrasound as something that is underrated or they not taken seriously enough, and that's the Band-Aid part. That's where we're able to elongate the life of that bearing, just by putting a couple of shots of grease in it. And that's probably the least cost that is involved in repair that bearing or that equipment. And so I would look at it as the ultrasound is probably the most overlooked warning sign.
Hmm. Okay. And then Brian, from a maintenance perspective, what have you experienced?
But maintenance or not, that ultrasound is my answer as well.
Yeah.
That cost benefit, it's the best one in my opinion. Lubrication degradation is one of the leading failure mechanisms of all types of bearings, and it's very easy to overlook the effectiveness of ultrasound, and then the cost benefit of actually going out and greasing a bearing to a certain milliliter and then watching the dBs go away, right? So ultrasound is a huge one. People like to talk about ultrasound and things like that, but there's all different ways to utilize that from a cost-effective standpoint.
Awesome. All right. So Brian, where do maintenance teams most often get stuck when turning analyst recommendations into actual work?
That's a big question. Resource constraints. You have an analyst who understands what they're looking at and they know what they're looking at. You may have a maintenance team who really doesn't, right? So even if they make a really good, accurate recommendation that's pointed at that mechanism and very detailed, they may not be able to accurately achieve the result that was intended, right? So it's easy to get stuck with resource constraints and resource management skill sets, training, stuff like that, which is why it's super, super important that the analyst is integrated into your maintenance team. Even if your maintenance and reliability teams are separate, the analyst should be an integral part of enabling the maintenance team to do their best work through the technologies that they employ. So that's a big one, but I guess more so than a question, a recommendation and analysts need to be ingrained into the maintenance business. There's a tremendous amount of value there. That's why we have different skill sets. It's why there's experts in certain things and that aren't in other things, right? So that's my thought there.
Okay. And Todd, what comes to mind for you
Yeah,
this question?
I'm going to echo what Brian said because, when I was in the reliability team and working on equipment, that was one thing that I would ask from the maintenance department is, hey, I've got this piece of equipment that we've had this issue for quite some time. Can I be involved in the work that's going on that piece of equipment? I wanted to be ingrained into their team and actually be able to put my hands on that piece of equipment to fix what I was seeing and to actually get that bearing that I was calling bad and actually cut it apart and actually see the defect. Even now we go into facilities and we watch them tear down gearboxes to have a better understanding of what that failure mode is of that gearbox, because so we can look for that signature in the vibration data. And that's critical for a program to me, is to have that integration between the maintenance team and the condition monitoring team, because that relationship is key to being successful for an unscheduled downtime facility that we want to run.
Okay, thank you guys. I think this might be our last question. Brian, what's one simple change teams can make to get more value from their condition monitoring data that they're already collecting?
Do something with it. Break it down and do something with it, even if it's something super simple. Like, hey, we're going to bolt a guard on top of this shaft. So stuff stops falling on it and getting wrapped up in it, right? It doesn't have to be hard. There's always something that you can do. So I would just say act on the appropriate data and don't just collect data to collect data. And if an analyst gives you a recommendation, let them know it was wrong or it was right. And this is what we did. So it's very simple. Just do the work, act on the data.
Okay. And then Todd, what do you think?
Yeah, I mean the feedback that we get from the maintenance teams, that's critical to us in knowing, what they found. Even like Brian said, even if it was wrong, we need to know that because that makes us better, and that makes us, look deeper into our data and try to find that fault that was in there. And the data that the CMMS holds is crucial to the future of the company. I told many people that I supervised, I said, if we don't do it, the plant down the road is going to be doing it. If we don't do it, then we're going to be the one that's not going to be here. So, just like Brian said, do it. Collect that data. Be more reliable. Do the best of your ability for what you're doing for that repair.
Awesome. Thank you guys. Sounds like you're both saying just do the work. All right. Well, it's that time. We're at the end of the webinar. We really do appreciate you guys joining us today, and we look forward to seeing you at future webinars. Thank you, everybody.
Thank
Thanks,
you.
guys. Thank you so much.